So I want to start by thanking the three inventors of a very nice presentation that we just saw. And I want to shed some more light about the V concept as we say it in MIS, in the MIS cooperation, and of course with the three inventors. The V concept stands on a very solid three foundations. First one is, of course, the V3 implant, okay? And everything that has to do with all the advantages that the implant has, the final drill that is corresponded with the implant shape and prepares the osteotomy in a perfect way in order for you to place the implant in. And then, of course, the reduction of the compression on the cortical bone and the very nice anchorage that this implant has on the cortical area for great primary stability. The second part has to do with the aesthetics. Now, the aesthetics, of course, starts with the V concept, the greater volume of bone, soft tissue that can gather around the shaved area of the implant, just like we saw in the previous presentation. And of course, it's supported by the tulip shape of the prosthetic components that will realize in sustainable and healthy long outcome result for the patients. And finally, the simplicity that has to do with this magnificent concept. The simplicity, of course, is related to the MIS Make It Simple philosophy. And the nice thing about it is that you, as guys that place this implant or going to use this system, will not need to adapt any new protocol. You don't need to have any new learning curve. You just need to go through your regular procedures. If you used to augment in some cases, go ahead and do the augmentation. If, like we saw before, you are doing soft tissue grafting, go ahead and do soft tissue grafting. You will enjoy all the biological benefits by this system just because of the unique shaped head of the implant and the abutments. From technical point of view, I want to emphasize some things about the system. First of all, the range of the implant has 4 different diameters and 2 different platforms. This is the narrow diameter implant. It comes in lengths of 10, 11.5, 13, and 16 millimeters. And then 3 more diameters with the standard platform with the length, comes from a length with 8 until 16 millimeters. We have 3.9, 4.3, and 5 millimeters in diameter, all of them with the standard platform. One of the things that, don't start the movie just yet. One of the things that were bothering us about this system is, yes, this is a great concept. This is a great implant. This is a great idea, a great patent. But is this implant strong enough? We took a regular circular implant. We shaved some of the titanium off. This implant must be weaker. So we went and we checked it. In MIS, we have all the facility and all the machinery. You can start the movies now. We have all the machineries and all the facilities to do the fatigue test, torque fracture test, in order to get results. Of course, we need to have those results in order to submit for registration of the implant, but it was also important for us to see that our implant, the V concept implant, is as strong as a regular circular implant. And this was a great challenge for our engineering team. And by the way, the movie on the left that you can see on the left, the 5 million cycle pounding of the implant takes about 3 to 3.5 weeks until the implant is fracturing, and then you have a reading. We went with those numbers that we got of the implant, and we checked some of our competitors. This was free data. It was published. You can see data by Nobel, by Biomed 3i, and by Straumann, comparing always the narrow diameter implant, because the narrow diameter implants are the weakest ones. And you can see the numbers after 5 million cycles. You can see on the Nobel chart, they compared the Nobel Active to the Astra implant, and they got a reading of 160 newtons compared to 130 for Astra. And then on the Biomet 3i publication, you can see the comparing between Straumann bone level, Biomet 3i, and the Nobel replace, and you can see the numbers. And then even the rock solid metal by Straumann, which shows really high numbers in comparing to the Nobel Active, Nobel Replace, and other Astra implants. You can see the numbers. Those were the test of the V3. Much higher of them all, around 370 newtons. And that was a very important thing for us, to secure the strength of the implant and not to compromise on it. This is a chart that summarizes in more graphic way everything that I just showed you. What will you get? In a single implant package, you will get, of course, the inner sterile tube, the outer tube, a cover screw, the implant, and a final drill. And I want to say some word about the final drill. We are very lucky in MIS to have the ability to deliver a final drill with each one of the implants. It gives us the ability to control the insertion torque of the implant. And this is very important, because we can adjust always the final drills, which we produce in-house in MIS, that it will go corresponded with the implant body to get the optimal torque insertion of the implant. Of course, it is always sterile. It is always sharp. Nobody used it before. Nobody will use it after. It's sterile. You take it out of the package immediately prior using it. It's single-used. It prepares the osteotomy to the exact size and shape of the implant. Each one of the final drills looks a little bit different because each one of the implants is a little bit different. And it has great bone collection ability, as you can see in those pictures. So this is a really great advantage of this system. In regard of the aesthetic or the prosthetic component, as we speak, we have in stock ready more than 350 different prosthetic options or solutions for this system. And this is a lot, and it's covering everything from healing cup, impression cupping for open and closed tray, temporary restoration from a PEEK and from titanium cemented restoration, screw retained on UCLA or on a multi-unit, and of course, all the CADCAM solutions. But the nice thing about it is that they all have the same emergence profile. Just like Nitzan was showing previously, you get the same emergence profile. You don't need to hurt the tissue when replacing the part throughout the procedure, from impression taking through the final restoration. You can see it here on an X-ray. Very nice. In regard of CADCAM, CADCAM is really evolving into our industry in the last couple of years, and MIS has a full range of solutions and supporting CADCAM in our inventory, starting in a regular titanium base with 4 millimeter pillars with different gingiva heights of 1.5 and 3 millimeters, anti-rotation mechanism for single tooth restoration and free rotation for multiple tooth restoration. We have a special T-base with a 6 millimeter pillar in case you do cases of central or lateral incisors and you want to have better engaging point with the crown. And of course, we have, just like Eric showed, great solution for scan post made out of titanium with a patent on the coating of the metal for excellent surface reflection to the scanner. We have one for the implant level and another one for the multi-unit level. Here you can see a demonstration of some of the very nice and very good reflection that those scan body reflect to the scanner, and you can see the outcomes. Of course, in regard of CADCAM, you can get CADCAM restoration in two different options. One of them is using one of the centers that MIS has in the US, in Germany, and in Israel, which in those centers we can either take an STL file that was provided by you and just mill it and create bars, full arches from cobalt chrome, from titanium, one-piece titanium, zirconia abutment on multi-unit, on T-bases, and so on. Or we can even do the planning and creating the structure of those abutments and crown in-house. Or you can just go and refer to your lab that you work with. In 90% of the cases, the MIS titanium base and implant will be implemented in the dental lab software libraries, so you can go either way. The last foundation of the V concept is, of course, the simplicity. A good example to reflect this simplicity is using showing how does the delivery system of the implant works. First of all, we have grooves that marking 3 and 6 millimeters. In case you do flapless cases and you want to know when the implant is going down to the bone level, or if you want to submerge the implant a little bit down the crest, then you have grooves on the surgical delivery tool that can show you exactly where you are when you look at the gingiva. Secondly, a very easy and friendly to use click mechanism will let you know when you hooked into the implant in the sterile tube, and you will be able to take it out very easily. Another thing that you can see very clearly, and we can saw it in Eric's movie, very nice, is that the flat surfaces on the implants are always corresponded with the flat surfaces on the delivery tools, on the insertion tools, give you a clear indication of where is the flat surface of the implant when you want to place it, and you can, of course, adjust it to the right position that you want. You can see it here, very nice. Our surgical kit. Our surgical kit is very advanced in the way it was designed, in the way it's shaped, but it's still very simple to use. It has minimum tools in it, but for maximum efficiency, the MIS philosophy is always to keep it simple, to give you the mandatory tools that you need, but we don't want to overload our kits, not to have too many drills, stoppers, and so on. We have it, just the minimum tools that you need, but for maximum efficiency. There's a single hand opening mechanism for this kit, which is nice to have, and there is a smooth surface of the tray for easy cleaning and for easy sterilization process. If we dive into the surgical kit to see exactly what components do we have over there, then you can see that on the left-hand side, on the left-hand area, we have the starting drills, 3 different starting drills that you can choose in order to start your procedure. The ball one, the spade, which can act also as a bone mill if you want to work with it horizontally to flatten your ridge before starting to drill with it, and the positioning drill, and then a set of 5 different pilot drills with built-in stoppers that will assure you a very good and precise initial drilling. Only 3 twist drills in order to complete a full drilling protocol. Okay? 3 drills, 3 millimeters, 3.5, and 4 millimeters, and of course the body try-ins. The twist drills has a guided tip, always corresponded with the previous drill, that will make sure that you are in the osteotomy and you have a very accurate starting point. For those of you who don't use MIS implants just yet, I will show the color coding system by MIS. It's very simple and very friendly. Those are the labels that you will find on top of the implant boxes and on top of the implant tubes. The upper color is corresponded with the implant diameter, and it's corresponded with the drills that you will find in the surgical kit. You only need to match red for red, blue for blue, green for green, and that's it. The lower part of the label is corresponded with the color coding of the platform. We spoke about two different platforms, narrow, which is blue, and purple, narrow, which is blue, and purple for the standard platform. So this is very easy to manage. Again, make it simple. On the highlighted area on the center of the surgical kit, we can find the insertion tools for the V implants, 2 insertion drivers for the motor, a short and a long one, and 2 for the ratchet. Each one of them has the color coding indicated the platform that you can use it. And on the lower part of the surgical kit, you can find an additional tools, the ratchet, probe, long and short prosthetic screwdrivers, extractors, in case you need to extract the abutment from the precise fitting implant abutment conical connection, and a drill extender. Of course, we also have additional tools to support with this system. A lot of them are ready for you. As for now, not all of them are in the surgical kit, but for example, a torque ratchet for implant placement. Thank you very much.